Let's measure. Join me for a little breast ultrasound registry review as we explore the proper way to measure a breast mass. So let's discuss the proper way to measure breast ultrasound masses. I included this image here as an example of what not to do. Never measure multiple times on the same image. If you have to take more than one set of measurements, you want to do it on more than one image. This not only is more professional looking, but it's not so jumbled and there's less chance that the measurements will be intermixed with each other. The goal of measuring a breast mass is to make sure that you provide a length, a height, which is the anterior posterior dimension or the AP dimension, and the width. The longest lie of the mass should be followed, unless the longest lie strays too far away from the length, height, or width dimension, meaning that the mass is too far on its side. The longest lie means the longest length of the mass. These are examples of correct length and height measurements. Length is the longest lie of a mass, which maintains a horizontal plane, although there's usually going to be some level of obliqueness to this measurement. And then height is 90 degrees perpendicular to the length measurement. So you want to maintain your horizontal and vertical planes as closely as you can, but you also want to make sure that you are measuring the entirety of the length of the mass. So if you do these exactly in a horizontal plane and exactly in a vertical plane, you may be missing or cutting off part of that mass. Additionally, whatever level of obliqueness you use to measure your length, your longest lie, you want to make sure that your vertical plane is going to be exactly 90 degrees perpendicular to this for the most accurate measurement. And then a correct width measurement, you want to maintain a horizontal plane as closely as you can, although again, there will be a degree of obliqueness to this, and then measure the longest width that you can. So what do you do when your mass is really oblique? And a true longest lie measurement would be a poor representation of the measuring plane, meaning that you've just strayed too far away from a true horizontal or a true vertical plane. In this case, the longest measurement, the longest lie that maintains the measurement plane is used. So you really want to use reason. You don't want to go too far off of horizontal or vertical plane. If you do, you're really measuring in a different dimension than the measurement you're trying to achieve. So in these examples, the red measurements follow the longest lie, but they're just really far away from a true horizontal and a vertical plane. So these three measurements no longer are following, length and height and width planes. What you need to do is use a reasonable judgment. The black measurements make the mass measure a little bit less, but they're really closer to what a true length and height and width plane would represent. So in this case, the black measurements are what you would want to do for this mass. Here we have an actual breast mass that we're measuring. When measuring the longest lie, the longest length should be found. We call this the longest lie, even if it's in a slightly oblique orientation, and measured. And this gives us a true representation of the size of a mass. Let's discuss lobulations. When measuring breast masses, it's really important to pay attention to the margins of a mass. First margin type that we'll discuss are macro-lobulations, and these are large lobulations on a mass. When measuring, macro-lobulations should be included in the measurements of the mass. And you also want to ensure that while you're including these macro-lobulations, that the longest lie of the mass is also measured. Another margin type to discuss are micro-lobulations. And micro-lobulations are tiny lobulations of a mass. When measuring, micro-lobulations should be included in the measurements of the mass, and also ensure that you measure the longest lie of the mass with the micro-lobulations. Now let's discuss artifacts. Edge shadowing is a common artifact that we see on the sides of a mass. And it's really important to recognize edge shadowing as an artifact and ensure that it is not included in the measurement of a mass. Measuring hematomas. A hematoma is basically a pocket of blood in the breast as a result of trauma. And a hematoma's appearance depends on the age of the hematoma. The echogenicity changes over time. When a hematoma is fresh or acute, it's anechoic in appearance. As the hematoma ages or coagulates over time, it gets more hyperechoic. On ultrasound, we most classically see a hematoma with an inner anechoic space and an outer hyperechoic space. Measuring the outer hyperechoic border of the hematoma will let you know over time if the actual size of the hematoma is decreasing over time. Measuring the inner cystic portion of the hematoma will let you know if the hematoma is coagulating or changing appearance over time. Over time, that cystic portion should start to go away, and the hematoma will become completely echogenic as it coagulates. So depending on the protocol of your breast center, some breast centers measure just the outer hyperechoic portion of the hematoma, or some breast centers measure both the outer portion and that inner cystic portion when it's visualized. The most important thing is to follow the protocol of your breast center. Next, let's talk about field of view and measuring. To accurately measure a mass, all margins of the mass must be visualized. You want to use the smallest field of view that allows all the margins of a mass to be seen. In these examples, the first field of view is the linear field of view, and you can see that it cuts off the sides of this mass. So if we measured with this field of view, we would get an inaccurate measurement, and the mass would be measured smaller than its actual size. In the next field of view, the sector field of view, you can see that the sides of the mass are still cut off. So this would also underestimate the mass size. When neither a linear field of view or a sector field of view can display all of the mass margins, it's time to move to a panoramic or a seascape image. When we use panoramic imaging for this mass, you can now see that all sides of the mass are visualized, and this will allow for a more accurate measurement of the mass. Next, let's discuss measuring a mass in tissue with a host response. A thick echogenic halo around a mass, also known as desmoplasia, is the host response of the tissue reacting to the mass. For desmoplasia, the mass is trying to expand via angular margins, spiculations, and grow bigger, while the body is trying to fight that. And the body fights it by building a ring of fibrous tissue around this mass to try to stop its growth. And this thick fibrous tissue that the body is using as this host response, we call desmoplasia. On ultrasound, it appears as a thick echogenic halo. It's important to note that this is actually part of this mass, and this thick echogenic halo should be included in the measurement of the mass. Angular margins are the pointy margins of a suspicious mass. Angular margins should be included in the measurements of a mass, just like lobulations. Also important, like with other types of mass margins, to make sure that you're measuring the longest lie of the mass while still including the angular margins. Spiculations are long lines of tumor extension that protrude from a mass. Think of octopus legs. Spiculations should not be included in the measurements of a mass. On these images, you can see where the two red arrows are. These are showing the spiculations that are coming off the edge of this mass, and note that they are not included in the measurement. One of the hardest things in breast imaging is ensuring that you're seeing the posterior margins of a mass. Worrisome masses are thick and dense, and they're hard for the sound waves to penetrate through, and the result of this is that the posterior margins of them are very hard to visualize. When you come upon a suspicious looking mass in the breast, until you get really familiar with looking at breast masses, the first thing you you should do is decrease your frequency quite a bit. Decreasing your frequency will let you look at that mass and truly see how deep it goes in the tissue. And then once you can visualize that posterior border, you can go ahead and increase your frequency again to take your images. You can see in these two images, the red arrow is showing that at least half of this mass was not measured. When the true borders of the mass are measured, the mass almost doubles in size. So this is how critical finding that posterior or deep margin of a mass is. Here's another example of a mass that was really underestimated in size. This mass was extremely dense, and the posterior margin of this mass is incredibly hard to visualize. Dropping the frequency in this case and increasing the TGC in the far field would have made the posterior borders of this mass visible. When the true margins of the mass are measured, you can see that the mass easily is double the size as the initial measurements. Measuring normal lymph nodes. The longest length or longest lie of the lymph node should be measured. Most commonly, this will be at an oblique angle. The outer cortex, this is the hypoechoic portion of the lymph node, should be included in the measurement of the lymph node, as it's actually part of that lymph node. When measuring abnormal lymph nodes, just like when measuring a breast mass, you want to make sure that lobulations and the irregular margins of an abnormal lymph node are included in the measurements. It's critical to ensure that this thickened outer cortex is included in the measurement. Measuring a ductal mass. Sometimes with ductal masses, we can actually visualize the duct in addition to the mass, and sometimes we can only see the mass itself. When you can visualize the duct in addition to the mass, it's really critical to ensure that you're measuring only the mass and not the anechoic milk duct. So only the solid component of the mass itself should be included in the measurements, and important to follow the longest lie of the mass. Measuring material that's spilling outside of a duct. Any solid or fluid portions outside the duct should be included in the measurements, but the actual duct itself should be excluded from the measurement. Measure the mass, but not the duct. When measuring a cluster of cysts, it's important to measure the cysts along the outer border of the cluster of the cysts, and also to measure the longest lie of the cluster of cysts. A cluster of cysts will have lobulated edges, and it's important that these lobulations be included in the measurements of the cluster of cysts. Think of a cluster of grapes. You'd want to ensure that you include all the grapes, especially the grapes along the outer borders of the cluster within your measurements, and also ensure that you're following the longest lie of that cluster. In breast ultrasound, we commonly search through the breast tissue to see if we can find a correlate for mammographic distortion, and often these areas will have little cysts associated with them. The little cystic areas and the solid portions of the mass should all be included in the measurements of the mass, and the longest lie of the mass should be measured. When you come across a cystic mass that has a solid component to it, it's critical that you measure both the outer cystic component of the mass. This shows the true size of the mass, and also measure separately the inner solid component of the mass. And it's important that these two measurements are done on separate ultrasound images and not done all on the same ultrasound image. Both the outer cystic component and the inner solid component should be measured in 3 dimensions. To measure a mass that has posterior shadowing, exclude the shadowing from the measurement of the mass. And you do this by trying to delineate the posterior margin of the mass itself separate from the shadowing as best you can. One trick is to really lower the frequency, and while you're scanning real time, this can help you see that posterior border, and also turning on the mass in several different dimensions will help you get a sense of where that posterior border is. Once you have visualized that posterior border, you can increase your frequency again to take the images. The shadowing should not be included in the measurements of the mass. When measuring a well-defined mass in the breast, such as a cyst or a solid mass with well-defined margins, the mass should be measured from outer edge to outer edge, following the longest lie of the mass. It's really tough when you have an ill-defined mass to figure out where the borders are. Best way to figure out where the borders are to really carefully study the tissue around the mass and look for things that you can recognize, such as what does the glandular tissue pattern look like around the mass? Where's the pectoralis muscle? And then once you establish what that tissue pattern looks like, look closely at the mass and turn on the mass from multiple different planes. Try radial, anti-radial, sagittal, transverse. And as you're turning on this mass, this will help you start to see or define the borders of the really ill-defined mass. It's really critical to be able to see the borders and figure out where they are so that you can get an accurate representation of the size of the mass. Here's a little tip. So how do we distinguish between a thick echogenic halo, this is our desmoplastic reaction around a mass, and a hematoma? Well, the first thing to look at is what type of tissue is it in. Hematomas are going to be superficial. They're almost always in the superficial fat layer. So that's clue number one, where a desmoplastic reaction around a mass, that mass is going to be in your glandular tissue layer. Clue number two, if you see an anechoic space within a mass, most likely this is going to be a hematoma, although this can vary depending on the age of the hematoma, where a mass with a thick echogenic halo more than likely has an irregularly shaped hypoechoic area within that thick desmoplastic reaction. Clue number three is going to be to turn on color. A hematoma should have no vascularity, and a mass should have vascularity. Although I always say not all masses follow the rules. If your area has vascularity in it, this is going to be a mass with a desmoplastic reaction. Next, how to distinguish between a thick echogenic halo, this is our desmoplastic reaction, and just normal glandular tissue that's surrounding a mass. A thick echogenic halo is going to have hazy margins, and they're going to really blend into the surrounding tissues. And they'll often be slightly darker in echo texture than the surrounding glandular tissue, where normal glandular tissue that surrounds a mass is going to be contiguous with the surrounding glandular tissue, and it's going to appear similar in echogenicity and appearance to the nearby glandular tissue. Why is it important to establish if something is a thick echogenic halo, which is our desmoplastic reaction, versus glandular tissue surrounding a mass? The importance of this is the desmoplastic reaction is part of that mass and should be included in the measurements of the mass, where normal glandular tissue surrounding a mass is not part of the mass. It's just part of the normal glandular tissue layer, and that should be excluded from the measurements of the mass. Breast ultrasound measuring 101 tip. Don't measure fat lobules. Fat lobules always look like masses. Sometimes they look like a mass all on their own, and sometimes they look like part of an actual breast mass. Now, how do we stop measuring fat lobules and determine that these areas are fat lobules versus an actual mass? And the answer to that is very simple. Turn on your mass before doing any measurements of it. You should visualize a mass in multiple planes while scanning in real time before you try to throw any calipers on that mass. As you turn on masses, fat lobules are going to extend, they're going to connect with the rest of the fat in the breast, most commonly, or you may just have a fat lobule that's within the actual breast glandular tissue. You're going to be able to see the echogenic Cooper's ligaments within that fat lobule, where a mass is not going to have echogenic Cooper's ligaments running through it. So as you turn on this mass, these are clues to help you determine, is this fat lobule or is it actually a mass? So in the mass in this example, this mass in one dimension looked like quite a sizable mass, and that's how the mass was measured. measured. When you turn to the other imaging plane, you can actually see that the posterior border of this area that was measured is actually just a normal fat lobule that's within the tissue. Another thing to really pay attention to when you're measuring masses and trying to figure out where the borders are is that masses are dense and they're going to really impede those sound waves. You're going to have attenuation of that sound wave through the mass. Because of that, it's going to make any fat or any tissue that's below it look darker. It may not be true, dense, thick shadowing. It may just be a fat lobule under there that suddenly is darker in color, which can make it look like part of the mass. So really important to pay attention to, number one, does it have any Cooper's ligaments in it? Number two, when I turn in a different dimension, does it start looking more like a fat lobule? And these are clues that will help you ensure that you don't include fat lobules in the measurements of a mass. Fat lobules should always be excluded from the measurements of a mass, and just the mass itself should be measured. Interested in more videos on ultrasound? Don't forget to like, comment, and subscribe, and stay tuned for our next videos on Wednesdays.